Hi, hello. My name is Zakar, and I quickly want to tell you about this design and decision support tool which we have developed at IRT Systemics as part of the Anthropolis chair. Just to start with, what is the objective, what is the method behind the tool itself, and how are we using it? First, we are using this in the context of urban mobility, and we see urban mobility as a complex social-technical system which has a lot of weak problems, referring to problems which don't have one singular solution and which have a lot of different stakeholders involved. In this case, we require systemic transformation, for example, regarding environmental impacts, social impacts, and accessibility, and so on. And this is not just one indicator, such as greenhouse gas emission reduction, but also energy consumption, health benefits, and so on. Third, we are lacking tools or support methods which can simplify this complexity, once from the difficulty of the system in itself, so all the different components, all their interrelations, and secondly, the future uncertainty, which means we do not know how things will develop in the near future and what possible impacts that will have. So what we are proposing as a response to that is to create a support tool for designers and decision makers to assess the effectiveness of possible interventions in urban mobility systems. This is one possible application, which we are showing here. Just briefly to dive into the method and the tool. So we're building the whole thing on futures foresight, and here you see one of the visual artifacts of that field, which is the futures cone. So as further we go in the future, as more uncertainty we have, as more different possible futures we do have. And here we are working with two distinct concepts. One's scenarios, so scenarios defined as distinct, plausible alternative future states, which are not just a numeric description, but also have a narrative. And secondly, uncertainties, which are anticipated future developments, which, however, we do not know exactly how they will be, and thus they will have a significant impact on the futures or on the scenarios of the future. Then here you see a screenshot from the tool. It's accessible via the link at the bottom, as well as the underlying code. And importantly, on the left side, you have a sidebar, which is independent from the rest, where you can see the process and the glossary, where you can always show the scenarios and the personas. We'll come to that in a bit. And then on the right side, you have the main part, which is mostly consisting of three components. The first one is where you can define scenarios, personas, parameters. The second one is where you can compare different indicators. And the third one is then where you define possible interventions and can compare the impacts of them. All right, let's have a look at it. So here on the left, you can choose. In this case, you see the hyperlinks of the glossary. The right side, you can, for example, change the number of scenarios. Then a new field appears, which you can give a name. Just going through it very quickly here to give you a bit of an idea what it is about. So here, for example, it's a name. It's urban decay. Then you have a quick description. You can change different characteristics for it. For example, here you see the likelihood of a particular scenario to have a high level of public transportation or other categories. Then here you can upload visual information and you see a bit of an overview. The same idea for personas. So how many personas do you have? What are their names? What are the descriptions? What are the characteristics? All of that is pre-filled with sample data, but you can change it in whatever way you would like to. Then here, for example, I just changed the name and the age. Also, there are two different information which are quite crucial. So there is the distance. Distance is the total daily distance people move in one day. So for example, you go 30 kilometers in the morning to go to work, 30 kilometers back. And the body weight is the basis for the calculation of calories which are burned on a normal day. See the sample personas here. Then, because we added a fifth scenario, we need to adapt the likelihood because they need to add up to 100. So it's, in this case, for example, the first scenario is 3 times as likely as the fifth one, just because we assume it is closer to what we expect to happen. How many people are we looking at? So here we're looking at the plateau just south of Paris and can be 40,000, 50,000 people. Then for each of the different scenarios, we're looking at the impact or the likelihood that a particular mode will be chosen by one persona in one context or the other, so in one scenario or another. You see some initial comparisons of emissions and so on, and then comes the interesting part. So what interventions are there, and what is the change, the likelihood of a mode being taken, which results from that intervention. And then finally, you have the comparative graphs. So you see here CO2 emissions, the energy demand, the calories burned once individually for each persona, so one person, and the other time all of the personas, depending on their weight and depending on their distribution, together. Then lastly, the use case. So we invite you to try out and see how it works for you. And for this, as just mentioned before, we're focusing on Paris-Saclay, which is just south here of Paris. And we ask you to imagine that you're in a situation where you are tasked to reduce CO2 equivalent emissions as well as energy demand from mobility and improve public health in this area. So for that, two particular tasks, of course you can change whatever you wish, but we invite you to try to add a fifth scenario, and we will provide some sample information for that. And the second task is we want you to try to get an understanding of what the potential effects of a new mobility intervention might be. Again, we will provide some sample information, but you are free to use it with any other information.